Hey guys, Miss Higgins here. Welcome back to science. In our last lesson, we were studying how sound travels through materials like air, water, and even solid surfaces. Today, we're going to be studying collisions between particles in a wave. Remember that a collision means two or more things bumping into each other. We're going to study those collisions by observing slinkies, coin collisions, hand collisions, and the sim. So first, we're going to look at the slinky wave, and we're going to be thinking about how this could represent collisions between particles in a wave. So I'm going to show you a quick video of a slinky moving, and I want you to keep two questions in mind while you're watching. One, did the parts of the slinky move all the way from one side to the other? And two, based on this model, how would you describe the motion of particles in a sound wave? So let's watch this slinky video. Okay, so it's coming from this way. So the source is going to be his hand over here. Let's see what happens. Okay, so the energy is moving away from the source, from left to right. Okay, so did the whole slinky move all the way from one side to the other? No, it didn't. We saw that the energy came from the man's hand, and the source moved that energy across, but the whole slinky didn't move. It was only parts of it that moved. So based on this model, how would you describe the motion of particles in a sound wave? Well, it seemed like each ring collided with the ring next to it, and it was those collisions that transferred the energy from one side to the other. And remember, we know that energy always travels away from the source. So the source was his hand, and it moved away to the right. So we learned two important things here. Sound energy, just like the motion energy we saw with the slinky, sound energy travels as a wave. The particles of the material it travels through move only a little. So just like we saw, the whole slinky didn't move, only parts of it moved. Same thing with sound waves. Those particles only move a little bit. And the second important thing is that sound travels as a series of collisions between particles. Let's try another experiment. If you guys would like, you can do this as well. Please go get 1 nickel and 3 pennies. You can pause the video and come right back. Our first investigation is to place the nickel and 1 penny on the desk. You're not allowed to touch the penny, but somehow you have to make both coins move. In the second investigation, you'll put all the coins on the desk in front of you. Again, you're not allowed to touch the pennies. How could you make all 4 coins move without touching the pennies? You can pause the video quick and try this out. Now I'm going to show you a video of what this could look like if you did this investigation. Let's see how he makes these move without touching them. Okay, so let's watch that again. That was pretty fast. So what he did was he pushed one of the coins, and when that coin collided with the other ones, the energy transferred and it ended up moving the last coin. So he was able to move those coins without touching them. So we learned two important things here. Energy is what made those coins move. He didn't touch them, but the energy went through those coins. And second, the motion energy was transferred from one coin to the next when they collided. So how is what happened with the coins similar to the particle collisions that happen when sound travels? Take a second to think. Hopefully you said something like this. It's similar because in both models, particles collide. That happened in the sim and in the coin model. This causes some particles to move and some to slow down, just like when the pennies collide. Some pennies move and some slow down or stop moving. Today, you guys are going to try one final experiment called the hand collision model. So you have two choices here. You could actually make this hand collision model with whoever's at home with you. If you don't have enough people, feel free to watch one of the videos and you can watch someone do this hand collision model. If you would like to do it though, you're going to have people line up shoulder to shoulder. It doesn't need to be 8 people. The source will be on the left, the listener will be on the right. You're going to put your arms out in front of you, make your hands into fists, and your fist should be close to the fists of the people next to you, almost touching. Now the source is going to make a sound and gently bump the fist of the person next to you, and that person will bump the next fist, and you're going to pass the sound energy down the line. Okay, after you've made that hand collision model or watched a video of that model, then you're going to jot in the Google Doc. What repeating pattern did you observe? What direction did the sound energy travel? And what happens to the energy each time 2 fists bumped? Good luck and happy working. I will see you next time.